Hey, what's up everybody? This is Titans of CNC, and today I'm going to teach you how to program the TITAN-1M in Mastercam. All right, so before we get started, let's just talk about a few things that you're going to need, okay? Here is the print. It's a 3-part print. This is the exact same print we used in our last video when we taught you how to design the TITAN-1M. You'll need the setup sheet with all 5 tools and instructions. And then you'll need to download and then upload all 16 tools in the building blocks toolkit. All right? All documents and links are in related files attached to the TITAN-1M project. You guys ready to learn some crazy Mastercam programming skills? Let's go. All right, so let's get started. I'm gonna step up to machine. I'm gonna go pick out what machine I'm actually going to CNC machine this part on. And that would be our generic Haas 3-axis mill. Boom, all right. Now, here's something cool. I'm gonna teach you 2D toolpaths and some 3D. And the difference is the 2D will basically offset from these simple lines, and it won't have a brain, meaning it doesn't understand the part that it's machining. A 2D path simply knows that you told it to offset off a particular line, feature, contour, etc. All right? But a 3D toolpath reads the model. A 3D toolpath has the ability to understand and read off of the raw bar stock that you're cutting the material from, all right? And when one tool comes in and cuts part of the material away, another tool can come in and understand that part of the material was taken away, but there's still material in the corners. So let's not waste time. Let's drop into where the material has been removed and simply cut what was left over from the previous operation. All right, we call that rest machining. All right, let me stop there because I don't want to confuse you. I just gave you a little taste. All right, so to build the stock around the part, I'm simply going to go over to wireframe. I'm going to hit bounding box. Boom. Okay. Now I'm just going to click this guy and I'm going to say end selection. Oh, look at that. Looks great, right? When I look at my setup sheet, I can clearly see at the top it says 1x2 bar stock, cut 4.1. All right? So we're going to duplicate that minus the top material. Okay? So basically, we're going to put all the material around the outside, which is going to leave the material on the inside. We're going to put the material on the bottom just because, but the 20 thousandths per our setup sheet that I'm going to cut off the top is going to be done with a 2D path, and therefore it's not going to read the material, because when I bring up tool 2 to actually do the OptiRough path, it's just not going to care about the top because tool 1 would have already faced it. All right, so anyway, I don't want to confuse you, so let's just move forward. So we're going to come over here, lock this guy down, 4.1. Boom. All right, now we're going to go 2 inches. Boom. All right, now you can see the material all the way around the part. And now we're simply going to add the material to the bottom. Okay, so now I'm going to just click here, kind of just to show you guys, right? I don't actually need the material on the bottom, but I'm just going to show you how I would put the material there if I needed it. Okay, so I'm going to grab this guy. Look at that. Oh, so we can just bring it down. Now, I'm going to go 0.23. Okay, so 0.23, enter, enter. Okay, and now when you actually look at the size, it's 2 inches by 4.1 per the print, and then it's 980, which is 20 thousandths shy of the 1 inch. All right, and if you're wondering about the 20 thousandths, I didn't put it there, because on our operation setup sheet, if you go to the bottom, it says Z-axis top of part, and it says drop negative 20 thousandths for facing. So I'm basically with tool 1, I'm just going to face that off. If it's a 2D path, it wouldn't read the material anyway. So since I have experience, I'm simply not going to add it. And we are good. Okay, so I'm going to hit this guy here. Boom. And there you go. All right, so now we can actually see that the raw material is over my part and I can't quite get to my part. All right, so let's take this new model and drop it to a different level. Okay, so I'm going to click this guy. Then I'm going to come over. Remember this from the last video? I'm going to click select all wireframe. Now I'm going to come over. I'm going to right click. And I'm going to drop it to a different level. So I'm going to click here. And then I'm going to change it. So I'm going to unclick this guy. I'm going to put 3 here. Drop down. I'm going to name it stock solid. And I'm going to say OK. Boom. Now I'm going to come down to my levels. And there you go. All right. Now, okay, so now that we know how that works, let's actually go to the next step. So I'm going to come up to tool paths, and then I'm going to call this model a stock model by hitting here. So I'm going to say stock model. I'm going to name it stock model. Now I'm going to select it by hitting here, grabbing it, and hitting end selection. And then I'm going to hit the check. Boom. Okay. Now I'm going to turn this guy off, and you can see that the stock model is basically in the same position as the original model that I created with the bounding box. All right, so now that we have our material, let's actually do a little bit more housekeeping. I'm going to go to Tool Manager, and then I'm going to open this folder right here, and then I'm going to grab the building blocks tool list. And there's my 16 tools for the building blocks, all right? So as I said in the beginning of this video, it's important to grab this tool list from our academy. It's a free download, so grab it now and place it here before you continue. All right, so now I'm going to look at my setup sheet, and I'm going to simply pick the 5 tools that I'm using for this operation, all right? I'm going to grab this guy, bring it over, base mill, tool number 1, okay? Second tool is a 3/8, boom. Now we're gonna grab our 1/4 inch chamfer, which is tool 3, boom. And then we're gonna grab our .177 drill because we're doing a 1032 roll tap. I'm gonna grab this guy, bring it in. Then we're gonna grab our 1032 tap, boom. And there you go, our 5 tools. As I move forward programming with these 5 tools, I'll change the tool number so it reflects 1, 2, 3, 4, 5. All right, so we're all set. All right, so let's program tool number 1. I'm going to go over to our tool paths so I can see everything. You see our stock is right there. And I'm going to go up to base. All right, I'm going to go to my setup sheet. Tool 1 is a 3-inch face mill. So I'm simply going to come up here. I'm going to say face. Now you can see the toolpath populated, and instantly there's a box saying solid chaining. So what it needs me to do is select the surface that I want to face. All right, so to make this easy, I'm going to drop down here. I'm going to hit levels. I'm going to turn my stock model back on, and therefore I can select the entire surface going around. Okay, so I'm going to actually click this side, boom. And you can see that the entire box is now a chain. And now we see this box right here. So I'm going to say OK by checking it. Now I'm going to click down here. I'm going to say, yep, that's exactly what I want to cut. Boom. And now it's time to fill out all the information for the tool. OK, so we can see that facing is highlighted. Our geometry is 1 because we've picked the 1 surface. We're going to go into tools. I'm going to select my 1-inch face mill. I'm going to double check and make sure that my tool number and offsets are correct, and then make a few changes down here. All right. So spindle speed, I'll go 4,000. just to be safe, because we have a lot of students and first-time machinists following this video, we're going to keep our RPMs nice and low. Okay, so 4,000 RPMs and below. Change my feed rate. I'll go 25 inches per minute. Plunge rate will be 100 inches per minute. And go to holder. I don't really care. So I'm going to come over here to cut parameters. And because we're dealing with a 3-inch cutter and the surface across is only 2 inches, I'm going to change this guy to 1 pass. I want to go right down the center. You can see the green line right there. Boom. Right down the center. And now on our overlap, I'm going to put 120. I'm going to put 120%, which is going to allow us to start on this side off of the material and end on this side off of the material so that we don't leave any tool marks. All right. Now, over here, I'm going to just zero these guys out, and we're good. So I'm going to go to cut depths. This is if we're doing multiple passes and we're not. Okay, so let's just go to linking. Now this is important. Okay, so we're going to hit our clearance, which is our initial plane where we drop down to at the beginning. We're going to say 2 inches. That's fine. We're going to say only raise or fall to this position at the start and end of the program. All right, that's a safety thing right there. Okay, our retract is good at 1/4 inch, 0.25, and then our feed plane we'll keep at 0.2, which basically dictates when it starts feeding in Z. All right, I'm going to hit this guy right here and keep it absolute. Okay, actually I'm just going to go down and hit absolute all the way across. Whenever dealing with students, I like to start off with absolutes so we know exactly where we're at. All right, and that's why we've also kept our Z0 at the top of the part. That means everything above it is positive, everything below it is negative. When looking at code, it's just an easy way to know when you're engaged, when you're in danger, meaning when you're underwater, or if you're in the air and it just doesn't care. It's like a rap song, right? But it's true. If this is Z0, when we're up here, we're flying around. We have no cares in the world. This could be the ocean right here. But as soon as we drop below Z0, it's like bloop, 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 right? This is negative. Now, this is material. This is danger. You have to understand that at that point, you're either cutting material or you're in a pocket that if you move across, you'll actually scrap the part and crash the machine. And we don't want to do that. All right, so there's the reason behind our Z at the top of the part and keeping everything in absolute. So top of stock is 20 thousandths. Boom, that's up there. Our depth of cut is right at 0, right across that surface, and we're good. Okay, you can come down here, doesn't really matter, doesn't matter, doesn't matter. I can take the coolant here, I can actually turn it on, boom, and we're good. All right, so let's just click this guy, and there you go. All right, so that's the toolpath. We're going to drop down and go up. Okay, so I'll go over here, toolpaths. You'll see it right here. Now check this out. I can actually click up here, and it shows you the tools. All right, that's back plotting. So I can actually hit the play button. It'll show the tool come down, or I can stop. Now watch this. I'm going to hit the S key. Take a look at it. Make sure that you're perfect, right? And you can hit S again. Oh, it went way over there. What if I actually want to back up? Hit the B key. Boom, right? So it's like boom, 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 boom. Ah, okay, there you go. S and B key moves it forward and backwards. And here's something else. If you hit this guy right here, you can actually come in and say interpolate, and then you can set your step increment. So we'll go 0.2. Now say okay. I'll restart it. Now watch, I stopped it, S, it just goes 0.2. Boom. Cool little trick, right? If I want to back up, I can just back it up. I can move forward. I can double check everything. And I'm teaching you this right now because back plotting is incredibly important. And it is how you can ensure that your toolpath is actually great. And this is great because we want to actually proof out the tools right here. We want to have a clear understanding of what they're going to do right here in Mastercam, not when we're on the machine. All right, so I'm just going to OK that. And there's our first toolpath. All right, so now that our facing operation is complete, let's go ahead and move on to the next step. All right, so I'm actually looking at my model and I can see the material around it. And I can see that if I actually step up here and hit that guy, it gets dark, right? So that tells me that my other level is turned on. So I'm going to go ahead and turn it off. There, see, boom, boom. The only reason I turned that one on was that it allowed me to actually click the entire top surface from a face cut, all right? Now the only thing I have to worry about is my stock model, which is right here. And we're actually going to use it in the next toolpath, which is OptiRough, okay? So, all right, I actually want to get rid of that toolpath, so I'm going to come over here, click that, boom, it's gone. All right, before we get to the OptiRough, I'm going to go ahead and right click. I'm going to say top, boom, I'm going to push away. Now for OptiRough, I actually have to have a boundary, okay? So I'm going to actually create a boundary around the part. And an easy way to do that is simply going to wireframe, circle, I'll click here, pull it out, move away, pull it out, and I'll click, okay? Now I got this nice big diameter right here. I'm going to go ahead and click right here, boom, accept it, all right? And now that will be a containment boundary for my toolpath in OptiRough. So I'm going to go back to toolpaths. I'm going to go to OptiRough right here. Boom. Everything pops up. Toolpath, OptiRough, it's already highlighted. I'm going to go to geometry right here. And I'm simply going to click over here. Boom. And then I'm going to click the model. If I click one time, it'll be this surface. What I need to do is click it 3 times in a row to click the entire model. So I'm going to click 1, 2, 3. Boom. Okay. Now I'm going to say end selection. So we're good. Boom. Now when you look at this section and this section, this is the wall stock, meaning the wall stock here. This is the floor stock. The floor would be down in the pocket or on the top over here. That's all the floors, okay? And it's basically asking me, do you want to leave material on there? And since it's a roughing operation, and because I'm going to come back and clean it up with a finish pass, then I will take advantage of it. But let's actually do 5 thousandths, okay? 5 thousandths per surface. 0.005. 0.005. Now I'm leaving 5 thousandths on the walls, 5 thousandths on the floor, and that's it, okay? This box over here, just for reference, just for future knowledge, this is avoidance, all right? So just like I clicked the model as my machining geometry, if I actually had a vise attached to it or work holding, or I had anything that I did not want to touch, I would simply hit this guy, click it, it would rise up over here and I would say, how far do I actually want to stay away from it? 1/4 inch, 1/2 inch, whatever it is, I would put it right there. And then it would make sure that the tool path stayed away from that vise or that work holding. Okay, so moving forward, now we're going to go to boundaries. And guess what? We have a boundary. So let's click this. My solid chaining box comes up. So I'm going to switch over to wireframe. Then I'm going to click this guy. Boom. And that's all I need. So I'm going to hit the check. There you go. So I'll say inside, center, boom. That looks good. I'm going to go to my 3/8 flat end mill. I'm going to say this is tool 2. My feed rate will be 25 inches per minute. Plunge rate will be 50 inches per minute. Spindle speed, 4,000. Again, keeping it nice and slow for training purposes. Retract rate, it's rapid retract, so it really doesn't matter. We don't care about this guy, but we do care about this, okay? So now rest material would be the amount of material that we have left on the part. And we know that we have quite a bit of material, right? So it's 1 by 2 by 4.1, okay? We took a face off the top, so Z0, the top of the part, is perfect now. So basically we just need to come in, hog out this pocket, and go around the part, okay? So I'm gonna hit rest material. Now I'm gonna click here, one other operation, and check it out. It went to stock model. So I'm basically saying we're gonna take off the material from this other operation right here. Make sense? All right, so now we're gonna go to cut parameters. We're climb cutting at 25 inches a minute. Our tip compensation is at tip. We're going depth, material, and all of that is perfect. On my step over, I'm actually gonna go 15%. All right, so our step down is gonna be 200%, which is 750. We're gonna click step up. Then my step up, I'm just gonna put in 50 thousandths. Now what I know is there's no slopes, all right? If there was a slope, it would make a bunch of passes 50 thousandths up, okay? But here I could really put 50, I could put 250, 200. It really doesn't matter too much because once it reaches this level, it's gonna cut this level, leaving the 5 thousandths that we left in geometry, as far as on the walls and the floor, etc., right? So we're gonna say 50 thousandths. This guy, we're gonna say 20 thousandths. Lift height, that'll be every time it cuts and actually comes back. You can see it right there. It's gonna be at 10 thousandths. That's perfect. Back feed rate is at 100, which is also great. Now I'm gonna go to transitions. All right, so on my helix radius, I'm gonna come in here. I'm just gonna make this 150. Boom. That'll make it a diameter of 300 thousandths. Z.1 is fine. Plunge angle is 2 degrees. Leave that alone. And we're skipping any pockets that are less than 0.55. I only have a few, so we'll leave that alone also. What I will change is this guy because our standard feed rate is at 25 inches per minute. But I want to slow it down because our standard feed rate is 25 inches a minute. And I want to slow it down when ramping. So I'm going to take this, I'm going to actually go down to 15 inches per minute. I'll leave ramping speed at 4,000. And this would allow us to dwell at the bottom before we get into the material, but I'm going to leave that at 0. Now steep shallow, I'm going to click this guy right here, and that says adjust for stock to leave, which in the geometry, I left the stock here, and we want that stock to be left, so we're clicking this guy so it reads the other one. All right, makes sense? Now I'm going to click this guy, leave this at 0. I'm going to click this maximum depth, and then actually over here, I'll just put negative 0.750. Now we'll go to linking parameters. I'll leave this guy at 2 inches, absolute, full retract every single time. I'm going to leave that alone. I'm going to drop down 25, vertical entry 75, 75, 75, 75. All looks perfect. Ramp height 100. Boom, love it all. Then I'm going to come here. We're good. We're good. Coolant, let's turn the coolant on. Boom, we're good. And let's try out the path. All right, so this path looks absolutely fantastic. I'm gonna go ahead and back plot it. Toolpath's looking really good. You know, when you guys have a lot of experience and depending on the type of tool you're using, these step overs, which are just about 15%, you can actually increase those depending on your depth of cut and the ability of your end mill, all right? 15% was just safe, and therefore that's the number I used. All right, so next thing we're gonna do is actually finish the outside, finish this step right here, and finish the pocket. To do that, we're gonna use the exact same end mill, tool number 2. We're gonna hit contour, and boom, you see contour pops right down here, and then we're ready to create our chain. I'm gonna start it right here. I'm gonna actually click this guy right here, unclick here, press shift, boom, and there you go, all the way around, okay? Looks really good, all right? I clicked the top here because the bottom was actually the bottom of the chamfer, and it was not the outside of the part, see? So I actually clicked the top line so I could ensure that I was on the outside of the part. Therefore, our finished pass will be perfect, okay? So I'm gonna okay this. All right, so we're contour. Our tool is tool number 2. Because we're in a different tool path, our RPMs have changed, so I'm gonna actually put 4,000 here. And I'm gonna change my feed rate. I'm just gonna go 20 inches per minute. Nice and slow. 100 inches per minute on the plunge. Retract, we're just gonna say rapid retract, and that looks good. Come over here, looks good. Cut parameters, I'm gonna actually turn on cutter comp. So I'll hit this guy, I'll go to wear, tip, everything here looks good. Cut depths, it's fine because we're going to 1 depth only. Lead ins, I'll go ahead and leave this alone right here. Everything looks really good. Breakthrough doesn't matter. Multi-passes does not matter. Tabs. Linking. All right, so I'm gonna go ahead and turn back on our clearance. I wanna make sure that it's just at the beginning. It really doesn't matter, but I'm just gonna click that guy right there. We're gonna keep on absolute throughout. So absolute, absolute, absolute. Our retract is 1/4 inch. Feed plane is 0.2. Top of stock is 0. Depth is 0. So we're actually going to drop down to negative 0.760. We're just gonna overshoot the part. The part is 0.750 thick, or 3/4 inch. We're gonna overtake it by 10 thousandths just to make sure that the entire surface that we cut is beautiful. There we go. Everything else is looking good. Coolant, I'll go ahead and turn on. And there we go. All right, so let me actually show you something right here. I don't want it to start in the center right here, okay? So I'm actually gonna go back and change that. So I'm gonna go into parameters. I'm gonna go into my lead in, lead out, and see this guy right here, enter exit at midpoint. I'm gonna uncheck that. Now I'm gonna okay it. Now I'm gonna grab it again. Boom. All right, so now it started at the beginning of the chain. Hit this guy, and there you go. That's the pass. Nice and perfect. Everything looks good. All right, so let's go do the next pass, and that'll be finishing this step right here. This surface on the bottom is a little bit greater than the diameter of the tool, so I'm actually gonna have to make 2 cuts coming in to make sure that I get everything, okay? So let's go. I'm gonna hit contour. I'm gonna come down here. Now when creating the chain, you can see that the chain here kind of dips in a way, right? It actually won't matter too much, but let's actually go up here, okay? Because once I put the depth, it'll all work itself out, okay? So I'm gonna hit this guy right here. Now, here's another little trick. See this? This little pointer right here takes the X forward. This one goes backwards. So I'm gonna go forward, 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 and then that's the exact chain that I want. So I'm gonna hit the check mark. Now, since we're using the same contour pass that we did previously, our tool 2 and the speeds and feeds should be the same, which they are. So I'm gonna just simply move ahead. Come to cut parameters. The wear is the same. Everything here looks good. I'm gonna drop down to depths of cuts. I'm gonna go lead ins. That all looks good. Now where it's gonna change is here, multiple passes. I'm gonna click this guy. I'm not gonna worry about roughing. I'm gonna come to finishing. I'm gonna say 2 passes. My spacing is gonna be 0.200. And then I'm gonna move forward. I'm gonna say final depth, and then I'm gonna say keep tool down. So when it roughs here, it just moves over instead of raising up and coming down. I'm outside of the part, so I have confidence, and that will work, okay? Now we're gonna go to linking parameters, and then I'm gonna put in -0.5 for my depth. I'm gonna say okay, and there you go. All right, so our next toolpath, we're gonna actually go up to 2D, drop this box down. I'm gonna hit pocket. Now I'm gonna simply click right inside of here on the bottom of my pocket. Let me switch it around so we can see it a little bit better. I'm gonna hit this guy right here, hold in shift, boom, all right? And that is exactly what I wanna cut, okay? So I'm gonna okay it. My box comes up. Now let's just simply go through the tabs. There's my tool 2, that's what I want. I'm gonna come over here, change my RPMs. I'm gonna go here, 20 inches per minute, boom. Plunge rate is 100. And retract will be rapid. All right, so that looks good. Now, one thing that I'll say is plunging straight down into a finish pass is not smart, but I'm gonna do something a little bit different and explain it, okay? So just stay with me. So holder, we're fine. Cutting parameters, we're climb milling. The pocket type is standard. Tip, sharp. Down here, we're gonna get rid of these guys, just put it at 0. Boom. Now that all looks good. Go to roughing. Our cutting method, there's actually a lot of different choices here, okay? But we're gonna hit parallel spiral. 50% step over is good. Distance, boom, everything looks good. Entry motion, I'm just gonna switch it up a little bit. I'll go 45 here, a little bit smaller. Over here, it says maximum. I'm just gonna go 50. Z clearance, where I start, I'm just gonna say 20 thousandths. 100 thousandths off the wall, sounds good to me. Plunge angle, we'll put 2 degrees. Tolerance, 5 thousandths. That's all fine. And there you go. So now we'll go over to finish. Make a couple adjustments. My spacing for my finish is going to be 5 thousandths. Compensation is going to be wear. And then we're only going to machine finish passes at final depth. All right. That's just the outside diameter finish pass. And that just means it's going to actually cut the bottom, and then it's going to come in for one final finish pass on the outside, which is exactly what we want. Unclick this guy. Lead in, lead out. Boom, boom. You know, I actually might change this a little bit since we're down in a pocket. The line doesn't need to be that long, so let's just make this very small. 50 thousandths. Our radius, let's put at 0.25. And then let's angle it at 45. Helix height, let's just go maybe 20 thousandths. And then just do the same thing over here. So we're gonna go 0.050, tab through, 0.25, 45, 0.02. Boom. All right, so we'll bypass this guy, go to linking parameters. Now, this is where it's gonna get a little tricky, okay? And a lot of people would not send you down into the darkness like I'm going to right now, but I'm gonna explain it, okay? So we're going to say clearance is at 2 inches. Everything is absolute. We're up in the sky, then we're submerged into the ocean, everything below 0. All right. You never want to wrap it. You never want to move fast when you're below 0, unless you're extremely confident. And that's what I'm going to talk to you about. Okay. So our feed plane is going to be -0.4. Our top of stock is going to be -0.4. And then our depth of cut is going to be -0.5. Now, why did I do that? I did that because I am confident that I actually came in and did an opti-rough pass and actually cleaned everything out and only left enough for a finish pass. When we run the part, we'll ensure that all the material is gone, and therefore, when I create my helical, I won't start at the top and waste a bunch of time dropping to the bottom. I'll actually drop down -4 because there's no material there. And then I'll start my helical down low, which will save a bunch of time, get me to the bottom. And then I'll just take off the 5/1000 that's on the floor and the walls. All right, does that make sense? So I rarely drop down below the top surface, but in this particular case, because we know it's roughed out, we're gonna do it. I'm gonna come down here. I'm just gonna say, hey, let's make sure the coolant's on. Boom. I'm gonna say okay, and there you go. All right, so check this out. If I hadn't put that -4 on the feed, we would be feeding from up here, like all the way down. Okay, but instead it drops into space, drops down, gives you a nice path right to the bottom, and then it starts cleaning up. All right, and over here, same thing. It goes up, goes over, drops down, and then it radials into the cut, nice and perfect, looks beautiful. Oh yeah, love it, love it. All right, so I'm actually gonna save this, make sure we're good. And that's it. Like, that's it for like the hard stuff. Now, everything else is going to be easy. Okay. Really easy. So let's go ahead and just start finishing up. All right. So the next thing we're going to do is we're going to actually create the chamfers going around the part. So we're going to go out here. We're going to go in here. We're going to step down by this wall and go here. Okay. And to do this, I'm going to show you 2 different deburr passes or chamfer passes. And, just so you know. So first one, let's go back into our toolpaths here. Go to contour. Now let's select the contour that we want. So I'm going to select here, hold down shift. Now watch, I can hit this, or I can actually hit this guy. I'm just going to say, yep, that's the direction. That's the direction. That looks perfect. Boom. All right, so now before I hit the OK button, I want to explain something to you. There's already a chamfer drawn here. So I actually went to the inside of the line, which kept me at the top surface. And I know that if I say do a chamfer from this line, it will automatically put the depth exactly where it's supposed to be, because I know that when we did the last video and I put the chamfers on, I did them at 10/1000ths per print, which is perfect. I'm going to hit OK. I'm going to go to Tool. I'm going to go down here to my chamfer mill. I'm going to call it Tool 3. Go down. Now I'm going to go 25 inches per minute. Plunge is 100 inches per minute. Holder's fine. Cut parameters. Now watch this. 2D, click contour type. 2D chamfer, boom. Okay, I got my wear on, left, tip, boom. All of this looks good. Okay, now here's the trick. Because I went on the inside of the line, I don't need to put a chamfer width because it knows exactly what to do. Okay, because I went on the inside, therefore at a 45, it will cut perfectly from that line. So I'm going to hit this guy. 0, come down. Now this is taking my tip and offsetting it off of my part. And since I have a 1/4 inch tool and half of that tool is 1/8 of an inch or 0.125, I'm going to go tip off at about 60 thousandths, okay? Boom. And that looks good. Now, cut depths, I don't worry about. Lead in, lead out. Everything looks pretty good, but we can tighten it up a little bit. So let's just go 0.05. Let's go 0.1. We're only doing a 10,000th chamfer, so a radius coming in at 100 thousandths is sufficient. 45. Tab right through. Boom. Just copy what we did previously. 0.1. 45. We already know. We don't care about that. We don't care about this. Coming over here. Now, we'll keep this at 2 inches. We'll keep the retract here, absolute all the way through. Now the difference here is top of stock is 0, depth is 0, because we already put in our parameters here, and this box right here dictates the cut, okay? So it's at a 45, so if it's 60 thousandths off, it'll go 60 thousandths down. Make sense? And it'll start from the line we selected, which was the inside. This looks perfect. Let's go ahead and check it. Boom. Okay. Now, one thing I'll say is we're going to actually go to the inside, and it's going to be an identical path. So how about we actually treat it like that? I'll just hit this. I'll right click here, copy, right click, paste. Now we have an additional contour down here for chamfer. Now let's go into the geometry. Boom. This box pops up. Right click, rechain, shift, click on the outside. Oh, look at that. It looks so good. Oh, it looks so good. Okay. So now I say okay. Boom. Okay. Boom. And there's another way to get it done. All right. And click here. Just say okay. And there's my toolpath. All right. Now, if I actually want to watch it, remember the S and B. S all the way through. B backing up. All right. Now let's actually zoom in. Let's actually come in here. Okay. Okay. Let's take a look. Oh, let's see it. Let's see it. Let's take a look at it. Oh, see that? See that right there? It looks absolutely perfect. Therefore, we can look at it, have extreme confidence that our toolpath is perfect. I'll hit play. Boom. Speed it up a little bit. Beautiful. All right. Check that guy. Now, as I stated before, I'm going to show you a few different chamfer or deburr toolpaths, right? So I'll go down and then, oh, model chamfer. Now, geometry, boom. I'm going to go on the inside line right here. And I'm going to say, that's what I want. Say okay. Now, avoid model. Let's just put like 30 thousandths here. And what that's going to do is it's going to make sure that your tool stays off of this surface right here. Okay? So you don't hit the part. All right? It's brilliant. Come back over here. Boom. Now, because it's a different type of toolpath, we have to go ahead and reselect. So 4,000. Let's go 25 inches per minute. Nothing major. 100 inches per minute. All of that looks good. Cut parameters. We got 50 thousandths right here. That's perfect. Actually, because it's a chamfer, let's actually use a bigger part of the tool. So let's sink this a little bit more so it goes off, and therefore I'm up here, which keeps the side of the tool closer to the part, which allows this chamfer to get closer to the edge. Okay, So let's actually go 90, which is closer to half the diameter, which is 125. Okay, so 90 plus 10, that gives you like 25 thousandths right here. Just keeps you nice and tight. Okay? Lead in and lead out. That looks good, that looks good, that looks good. I'm good with all of that. Boom, boom. Multi-passes. We don't care. Clearance. We'll leave this at 0. We'll keep this at 0.25. Feed plane at 0.2. Turn the coolant on. Boom. Hit this guy. And there you go. All right. So for those that didn't quite follow, let's actually walk through it. Okay. So I'm back plotting it. I'm going to play it. Now I'm going to hit S. I'm going to turn so we can take a look at it. Boom, boom, boom. See how it's off right there? Meaning off in a good way, like it doesn't hit. Hit B, hit S, it doesn't hit, right? So that's the cool thing about that toolpath right there. So we can go right through it, boom, come out, okay it, and now all of our chamfers on the top side are complete. Now we're going to take the chamfer mill, we're going to chamfer these holes, we're going to drill and tap, and the part on operation 1 for the TITAN-1M will be done. All right, so moving on, we're going to take that exact 1/4" chamfer mill and we're going to spot these holes for our 1032 tap. All right, so we're going to go to drill, boom, and now we just need to show the software the positions of each hole. So I'll click this guy, this guy, this guy, that guy, that guy, that guy, and that guy. And see, I went from left to right because I know my first part is going to be on the left side. And then if I have a second or third part, it'll be on the right side. Therefore, the tool will start on the left, working its way to the right, and then continue on down throughout the machine tool. So everything looks good. I'm going to go ahead and hit this check. Boom. I'm going to go to tool. Drill is already highlighted, so I'm going to go to tool. I'm going to click the same tool, 1/4" chamfer. I'm going to double check. Tool 3, tool 3, tool 3, 4,000. Feed rate is 10, and I will leave that alone. All right, nice and gentle. Okay, so I'm going to go over here. Holder is fine. Stock is fine. Cutting parameters is fine. Cutting parameters is fine. Everything is basically zeroed out. And we're on drill and counterbore. And I am good with that. Okay. So we'll drop down here. That looks good. That looks good. And now for linking, we're going to go ahead and hit our clearance. Click this guy. It says 5 inches. Let's just stay with 2 inches. Retract height says 0.5. That's fine, but let's just go 0.25. Again, keeping this absolute, keeping this absolute, absolute, absolute. Top of stock is 0. That is correct. The depth of the hole, when looking at this thread, I know that a 1032 thread is about 0.190 to 0.192. If you want to be real, it's probably 0.192 diameter, all right? And roughly, when dealing with a 1032, the lead-in or the chamfer on the outside, we want it to be about 10% of the OD, outer diameter, okay? So if we take 192 and we take 10%, which is about 19 thousandths, we add the 19 to the 192, we come up with 211 thousandths. Because it's a 45-degree tool, we divide that in half, we come up with negative 0.1055. That looks good. Come down here, coolant, turn the coolant on, say okay, boom, and there you go. Okay, so let's go up here, double check it. going to slow it down. Take a look really close. I'm going to actually slow it way down. Zoom in. Let's take a look at this guy. Boom. Oh, look at that. It looks so perfect. All right. So I'm going to speed it up. Boom. Boom. All right. So that looks great. I'm going to say OK. Now our chamfer is done and our holes are selected in perfect order. OK. So now all I have to do is actually copy this guy for the next two tools. So the next two tools is a drill and a tap that's going in the same holes. All right. So let's actually do that. So I'll come over here. I'll right click. I'll say copy. I'll come down here. I'll right click again. I'll say paste. And then I'll do it one more time. There you go. So this is the chamfer. This is tool 3. We're going to go in this guy right here, hit parameters. We're going to go to tool. I'm going to go to 0.177, which is the drill size for the roll tap, which we're doing a form or roll tap. And this is the hole size, okay? So I'm going to say tool 10. Let's change that guy. 4. Boom, automatically changes. I'll keep this at 4,000 RPMs. This guy right here, I'll go 20 inches per minute. Boom, that'll be fine. All right, that looks good. We already know I don't care about the holder right now. I don't care about the stock. The cutting parameters, let's actually peck it. So we hit this guy right here. On our pecks, let's do a nice small peck. So we'll do 50 thousandths. Boom. Then I'm gonna drop down, drop down, drop down. So when we look at our prints for the TITAN-1M, we can look at sheet 2 of 3. Down below, you'll see that it calls out for 7 times the thread, which is a 1032, and it says a minimum depth of 0.380. So what I'm gonna do is I'm gonna send my drill down 580, and then I'll send my tap down 480, which should give me the perfect thread at 380. All right, taps don't have a huge lead, so that should work out perfect. So right now, I'm gonna say negative 0.580, and that's one of the key things. You have to make sure that this drilled hole is deeper than the tap, because when the tap goes down, it's not cutting material, it's pushing material, and if it hits the bottom, it's gonna break. So negative 0.580. Now, because I copied this, if we come to coolant, it should already be on. So let's say okay, hit this guy, say okay, and there you go. All right, now let's actually go in, make sure, oh yeah, look at that, nice and deep, nice and deep. Boom, 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 boom. See, looks great. See, that's the cool thing. You know, a lot of people say, hey, you shouldn't teach programming before somebody learns the CNC. But I believe once you're on the CAD CAM, once you design the part and you know it intimately, and then you program it, then the fear goes away because you know that you have 5 tools. You're using a face mill, an end mill, a chamfer, a drill, and a tap. And you watch the simulation. And because you watch it, because you designed the part, you know everything intimately. Therefore, when you go learn the CNC machine, you know, I just need to make sure that I duplicate the process in the machine. I hold the material in a good solid vise, and I set my offsets for my tools and my fixture perfectly. And you double check everything, then you're gonna be solid, right? Because you watch this happen the entire time, okay? So I love that, boom. Now, let's just go to the next one, and you can see this is tool 4. Let's go to the next one, hit parameters. Now let's go to the tool. Oh, we're almost done. Ooh, this is good. So I'm gonna go right-handed tap. That is our 1032. Look down here. Let's just go nice and slow, 500 RPMs. 500, spindle speed, 15, it calculates perfect. all right? Now I just noticed I didn't change my tool number, so let's go ahead and do that. So it's tool 5, boom, 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 perfect, all right? Now you can see it's tool 1, 2, 3, 4, 5, perfect per our setup sheet. Let's move on, boom, boom. Come over here. Now up here, we're gonna say rigid tap, boom, right there. See, everything is blocked out because it knows it's going to go in and it's going to come out perfectly. Okay. Now we just have to go down, and then double check our depth. And over here, we're just going to say the drill was 580. So this is going to be 480. Okay. One thing that I'll say is tool 5 on this setup sheet is a roll tap, or a form tap that pushes the material, and when it pushes the material, it retracts the material at the same time, creating the thread. Now, if you're using a cut tap, your ID, or your diameter here, is going to be a little bit smaller, okay? And it's going to push a chip or pull a chip, and therefore your hole will have to be drilled in a way that allows for that chip to be pushed in front of the tap. All right, that's just a little word. There's different types of taps. So this is a roll tap, and this will work out perfectly, okay? Coolant is already on. That looks perfect. I'm gonna hit this guy, boom, go down, hit this guy right here, say okay. Now that looks good. I'm gonna watch it. Goes in, comes out. Goes in, comes out. Speed it up. You know, when you're actually programming, you know, it's important to double check everything. Did I go 580 or 480? My advice is, if you even double think it, if you even consider that you might have made a mistake, simply click and go back and double check. As a machinist, you gotta always double check. All right, look how easy that was. I went right back in, 480. Yep, I'm good. Super solid. And guess what? That brings us to the end of the TITAN-1M. I'm so excited. This is my first Mastercam program. It's the first one. There's going to be more. We're going to tear it up. We're going to take you guys to greatness. It's going to be amazing. Titans of CNC. Teaching Mastercam. Yeah. You guys have a great day, all right? Boom.